Okay, now I'm just going to run through naming some more, just to hopefully reinforce some of the basic rules with this. We look at the longest chain and we count the carbons in that. Now this is 1, 2, 3, 4. Now I've numbered it from right to left going this way, but it could have been possible that I would have had to number it from this direction as well, but we're numbering to give the double bond the lowest number, which in this case is going to be number 1. There's 4 carbons in there, so it's going to be bute 1-ene, and we have a methyl group here. It's on the number 3, so that becomes 3-methyl bute-1-ene. That's that one. Okay, now when we're looking at this one, we notice of course it's got the carboxylic group here, carboxylic acid group there, and then we've got a chlorine there. Now because it's a carboxylic acid, this carbon is always going to be the number 1 carbon. Now that obviously makes this the number 2, 3, 4, 5 and 6. Take care with your numbering. Often students tend to miss the first carbon in the counting. So obviously this is going to be a carboxylic acid with 6 carbons, so that's going to be hexanoic acid. Also, remember to include the "an", that often gets left out. The chlorine is on the number 3, so that's 3-chlorohexanoic acid. Now I just sort of throw in a slightly unusual one. Again, we've got a carboxylic acid group there, we've got a chlorine there, and we count to give the longest chain that includes the main functional group, which is this. So that's 1, 2, and if we go this way or this way, it's going to result in 3 being the longest chain, so that we'll just call that 3 for instance, and that is propanoic acid. Now on the number 2 we've got a chlorine, so that would be 2-chloro, and on the number 2 we'd also have 2-methyl, because there's a methyl group coming off. Notice we could have just as easily swapped these two around and it would have been exactly the same name. Okay, so this is going to be 2-chloro, 2-methyl. Now the order in naming with the C comes before M. Okay, remembering that if you use a di or a tri, okay, that is not actually considered in the alphabetical naming. It's the actual functional group's name that takes precedence in the alphabetical naming. Okay, let's move on to another one. Okay, now looking at this one, we notice there's an OH and a Br. Now the most important functional group here is the bromine, is the alcohol here, and we've got 1, 2, 3, 4, 5, 6, 7. Numbering from left to right, this would give this a number 3. Going the other way would give it a 1, 2, 3, 4, 5. 3. Okay, it would give it a 5. Being a bit dopey here. So that means we'll go with heptan. Remembering to leave the "an" in there. Dash 3-ol, and that means 4, 5, 6. The bromine's on the number 6. 6-bromo. Notice we don't number from this side. Once we've started numbering left to right, going this way, we don't change to come back this way. We're consistent with our numbering. Okay? And in this case, when we only have 1 carbon, it can seem a little confusing, but just try and stay focused on what's really there, which of course in this case is the functional group to do with a carboxylic acid. There's only 1 carbon, so this of course is methanoic acid. So sometimes the 1 carbon ones can trip people up, so just be aware of that. Now in this case we've got 5 carbons in this chain, going 1, to the side group here, 4, 5. And we've got an amine group coming off. Now this amine group, if we were to give it the lowest number, is on this carbon. We don't number it number 4, of course. We number it to give the lowest count, which would be from this side, so it would be number 2. So this would be 2 amino pentane. But we also have so we've got a 2 amino to think about. And then we've also got, on the 3, we've got a methyl group. So we're going to go 2 amino 3 methyl pentane. And that's that one.